If the function f where f of x equals 1 on x and the function g where g of x equals 1 on x squared, A, prove that g of f of x exists. To prove that g of f of x exists, we need to show that the range of the inner function f of x is equal to or a subset of the domain of the outer function g of x. And just like before, to do this, we draw a table and write down the domain and range of each of the functions. F of x is a hyperbola, and its domain is given from 0 to infinity, where 0 is not included. Sketching the graph of f, the range of f is going to be also from 0 to infinity, where 0 is not included. And so writing this in the table, the domain is from 0 to infinity, and the range is also from 0 to infinity. G of x is a truncus, and its domain is not restricted, and so the domain of g of x is going to be its maximal domain, which is going to be all real numbers except for 0. Sketching the graph of g of x, the range of g is going to be from 0 to infinity, and so the domain of g is going to be all real numbers except for 0, and the range is going to be from 0 to infinity. From here we can see that the range of the inner function f of x is a subset of the domain of the outer function g of x, and so this means the composite function g of f of x is defined, or it does exist. And so we need to state that the range of the inner function is a subset of the domain of the outer function, which can also be written as the range from 0 to infinity is a subset of all real numbers except for 0. And so therefore, g of f of x exists, or it's defined. B. Find g of f of x and state its domain and range. G of f of x is going to be g of 1 on x. And so wherever there's an x in g of x, we're going to replace it with 1 on x. And so this is going to be 1 on x all squared. Simplifying this, this is going to be 1 on x squared, which is the same as 1 on 1 times x squared on 1, which is equal to x squared. And so g of f of x is going to have the rule x squared. The domain of this composite function is going to be the domain of the inner function, which is going to be from 0 to infinity. And so the domain is going to be from 0 to infinity, where 0 is not included. To find the range, we need to sketch the graph of g of f of x. This will also answer part C of this question. G of f of x is a parabola, and we know how to sketch a parabola, and so we can use the first method to find the range of g of f of x. Sketching a parabola with a domain from 0 to infinity, we can see that the range of g of f of x is also going to be from 0 to infinity, where 0 is not included. And so the range of g of f of x is going to be from 0 to infinity, where 0 is not included. Let the function f where f of x equals log e x and the function g where g of x equals x squared plus 1, A. Find the rule for h where h of x equals f of g of x. F of g of x can be written as f of x squared plus 1. And now wherever there's an x in the function f of x, we'll replace it with x squared plus 1. And so this is going to be log e of x squared plus 1. And so therefore, h of x is going to equal log e x squared plus 1. H of x is the composition function of f of g of x, and so the domain of h of x is going to be the domain of the inner function, which is g of x. The domain of g of x is all real numbers, and so therefore the domain of h of x is going to be all real numbers. To find the range of h of x, we'll need to use the second method which I described in the summary video. And this is because the rule of h of x isn't a graph we have been taught how to sketch. For this second method, we need to determine the range of the inner function and make it the new domain of the outer function. We then sketch the outer function with this new domain, and the range of the outer function with this new domain will then be the range of the composite function f of g of x, which is equal to h of x. The inner function, g of x, is a parabola shifted 1 unit up. Sketching this, we can see that the range of this graph is going to be from 1 to infinity. And so the range of the inner function g of x is from 1 to infinity. The outer function f of x is a log function. Sketching the graph of f of x with this new domain, which is going to be from 1 to infinity, we can see that its range is going to be from 0 to infinity, where 0 is inclusive. And so the range of this outer function with its new domain is going to be the range of the composite function h of x. And so the range of h of x is going to be from 0 to infinity, where 0 is inclusive. And that's it for this video. Now that you have a better understanding of composite functions, log into the Maths Methods Club and click on Functions and Graphs. And then select Composite Functions. Here, you'll see a list of all the official exam questions related only to the topic of composite functions. These are all the questions that were asked from 2006 to the latest exam. Try to answer each one of these questions, as they will help you master the topic of composite functions and better prepare you for your coming SACs and exams.